Okay, so 2.6 is correlation or causation and interpreting slope and intercept. So if we think back to 2.5, we had the study with the biologist that was studying the relationship between the diameter of the plant and its height. And we came up with this regression line right here. If you want to look back in your notes. And remember, we know slope is whatever's in front of x, and the y-intercept is the number by itself because it looks like y equals mx plus b. Okay. All right, so looking at just the slope is this number right here. And remember, if we have a whole number or a decimal like this, if we have something not written as a fraction, we can write it over 1. Okay, and what we need to be able to do is interpret what that means. So remember, it's change in y over change in x. So the y value, remember we can write change in y over change in x. The y value, if you look back at your table or your graph, represented the height in feet. So we're going to write feet and height up here. The change in x represented the diameter in inches. So we can say for every 1 inch in diameter the tree grows, its height increases an average of 3.179 feet. So every time we're going to label our slope, and we're going to put what the x represented and what the y represents. And we'll read it. For every 1 inch in diameter, the height increased 3.179 feet. Okay, and then interpreting y-intercept. So this is my y-intercept right here. That number by itself. That's my b. My y-intercept is 1.536. This is your starting point where you cross the y-axis. So that is when the x is 0. So the x here was the diameter. So when the diameter of the tree is 0, the height would be 1.536 feet. So this is when whatever x represents is 0. Okay. And then we also need to be able to interpret the x-intercept. So that for that, you substitute 0 in for y and solve for x. If I substitute 0 in here, subtract 1.536 over and divide, I get negative 0.483. What the x represents is what happens when y is 0. So the y here we said is the height. So when the height of the tree is 0 inches, the diameter is negative 0.483 feet. Of course, the height of our tree is not going to be 0 inches, so it's okay that this is negative and it doesn't make a whole lot of sense. And then we're going to talk about correlation a little bit. We talked about correlation last time also. Remember, positive correlation is going to be something where your line is going up. Negative correlation, your line is going to be appearing to go down. No correlation, it's just all over the place. Okay. All right, now we need to talk about causation and correlation. So causation means something causes the other thing to happen. There's a direct relationship between the two. Okay. Correlation just means they happen to occur at the same time. So we're going to label either causation or correlation. Okay, so causation or correlation. It says the following graph depicts the relationship between the cells of ice cream and the temperature according to the weather recorded each day. So the hotter it is, the more ice cream they sell. There's a direct relationship between how much ice cream sold and how hot it is outside. It makes sense that one has an effect on the other. So this is causation. The hotter temperatures cause more people to want to buy ice cream. The lower temperatures cause less people to want to buy ice cream. compared to this one over here where it says Mexican lemon imports prevent highway deaths. And it shows that the more we import lemons, the less people are going to die on the highway, which is probably not really true, okay? Even though this has a very strong correlation, you can see our R number is very high here, very close to 1. How many lemons get imported does not affect how many people die on the highway. So this is just a correlation. Same with this one down here. We have the global average temperature versus the number of pirates. This is saying as the number of pirates decreases, the temperature rises. The one does not have any effect on the other. They just happen to both occur. So this is just a correlation. And it's positive because it's going up. This is also positive because it's going up. This one's going down, so it's negative. But it is just a correlation. And this says, is there any relationship between student scores on an examination and the student's cumulative grade point average upon graduation? So your scores on exams affect your GPA. So one does cause the other to be higher or lower. This would be causation. All right. Time to do your assignment. Remember to do odds on the new material and all of the review. Let me know if I can help.